Alright, so today I'm going to be going through a problem where a guy is pulling a large ice block on a rope. And so to start out, I drew the force diagram. So you can see, so the circle in the middle is the block of ice. Acting downwards is the force of gravity, and acting upwards on it we have the normal force, not the neutral force. And then the man pulling it, on my screen it's to the right, but it probably looks like to the left to you guys. He's pulling the rope at a 25-degree angle. So this is the force of tension from the rope, and then this dotted line right here is F prime X. That's the motion in the F direction. And then I have F prime Y right here to make a right triangle. And then the other force is going to be going to the left, and that's the force of friction. So the first part of the problem is calculate the minimum force needed to get the cube sliding. So what we're going to do here is I just kind of listed out some like basic things that we already know, that F prime X is going to equal the force of friction. And the force of friction is going to equal mu sub S. And label or listed above in the problem on Expert TA was that the mass is 47 kilograms, mu sub S, which is the static friction, the coefficient of static friction, is 0.1, and mu sub K, or the coefficient of kinetic friction, is 0.03. So I wrote out those, and the next thing that I did was I wrote out that the normal force is going to be equal to the force of gravity minus F prime Y. And so that I know that the normal force is going to equal F sub G minus F prime sine of theta, because that is what, according to the force diagram, that's what it's going to be equal to. So we also know that F prime X is going to equal F prime cosine of theta. So then the first thing we're going to solve for is going to be F sub prime, or sorry, just F prime, which is, sorry. Okay, so what we're going to have as our first equation is going to be F prime cosine of theta, which is going to be F prime X equals mu sub X times the quantity of the force of gravity minus which is just going to be the normal force, but it's written out as F sub G minus F prime sine of theta. So then we're going to go ahead and multiply the coefficient of static friction out into there, and then we're going to subtract or add the coefficient of friction, static friction, times F sub prime sine of theta over to the other side. So you're going to get F prime cosine of theta plus mu sub S F prime sine of theta equals mu sub S F prime, or equals, oh my god, times force of gravity. Sorry. So then we're going to pull out the F prime, and then we're going to get F prime times the quantity of cosine of theta plus mu sub S sine of theta equals mu sub S times force of gravity. So then we're going to go ahead and move cosine of theta plus mu sub S, I can't even see what I'm talking about, over to the other side. So we're going to get mu sub S times force of gravity over cosine of theta plus mu sub S sine of theta plus sine of theta. So then we're going to go ahead and plug in all of our things that we know. So we know that mu sub S equals 0.1. We know that the mass is going to be 47 kilograms, because force of gravity is just going to be mass times gravity due to acceleration due to gravity, which is going to be times 9.8. Then we're going to have over cosine of 25, because that's theta, it does equal 25, plus the coefficient of static friction, which is 0.1, times sine of 25, because again theta is 25 degrees. And we're going to go ahead and plug that in and solve, and we're going to get 49 newtons. Okay, so then part B is, what is this acceleration in meters per second squared once it starts to move, if that force is maintained? So this one didn't take as much time to solve for. So we know the equation is going to be F prime X minus the normal force equals mass times acceleration in the X direction. So we're going to go ahead and move mass over to the other side, because we're solving for acceleration in the X direction. So we know F prime X from the previous problem is going to be F prime cosine of theta. And we're going to have mu sub k because now we're moving the blocks. We're going to be wanting to use the coefficient of kinetic friction. And then we're going to have then we're going to multiply that by the quantity of mass times gravity minus F prime sine of theta. And then we're going to have that all over the mass. So once we plug in everything, we get 49 newtons times cosine of 25 minus 0.03 times the quantity of 47 kilograms times 9.8 meters per second minus 49 newtons times sine of 25. So I kind of ran out of room there. And we're going to put that all over 47 kilograms. And once you plug that in, your answer that you will get is going to be 66 meters per second squared. And when you're doing this, just make sure that you're using the right coefficient of friction, depending on whether the block is actually moving or not. And then also just make sure that you draw out in the very beginning your force diagram correctly, because that is going to have a lot to do with whether or not you get the problem correct. Thank you.